Well, good afternoon and welcome to Norfolk Constructing Excellence and a Happy New Year. My name is Warren Salmons and I'm your host today. It's my pleasure to welcome you all here to join us for today's event. So it's kindly sponsored by Clancy Consulting and they've put a lot of effort to helping us with today's event. It's a slight change to billing. Our previous speaker was unable to attend and he's been attending the birth of his child. So we'll forgive him that, and we are most happy to welcome Steve Murphy with us today. And his presentation talk will be about modern methods of construction and facing sustainable challenges in this new world that we're living in. A few parish notices before I start. I'll talk about the awards a little bit later and encourage you to put your entrances into them. But sadly, we'll start with some sad news, unfortunately. We recognise the passing of Mike Britch, who many of you will know him. He was a member of the Committee for Constructing Excellence from 2006 for 7 years. He sadly passed away at the age of 62. Most of you will know him from his time at NPS and Norse as the Chief Executive. He was also the chair locally of Age Concern. And obviously our thoughts are with his family, friends, former colleagues, and our hearts go out to them. In memory of Mike, there is a Just Giving page online with donations available to brain tumour research. So I'm sure if those of you wish to do so, it would be a very fitting tribute to make a small donation to that charity. So moving on, today we have today's talk, and Steve Murphy will be getting himself ready, I hope, and sharing his screen soon. He is from NetZero Buildings. He was also at Ilkley Homes, and he will be talking to us about their expertise and insight into the modular and MMC environment. After his talk, we will also be joined by Adam Simpson, Daniel Key and John Dixon, who many of you will know from Clear Consulting, Richard Utting Associates and Ingleton Wood, and they'll be joining us at the end of the talk to summarise Steve's thoughts. So over to you, Steve.
So has my shared screen come through?
Yes, you're good to go.
Excellent, okay. Welcome all. I'm struggling to get that into presentation mode, but there we go. Welcome everyone. As has been said, my name is Steve Murphy. I'm the Chief Executive Officer here at NetZero Buildings. We're just across the border, nestled between West Suffolk and South Cambridgeshire. We're a manufacturer of MMC buildings for the education sector, the residential sector, and we're starting to move into healthcare. So I'm going to do my best to meet the brief. I have relatively short notice to put this together, and I think, as Mark Twain once said famously, I've sent you a long letter because I didn't have time to send you a short one. So there's a whole bunch of content in here which could go on all day. So I'll do my best to do it justice without boring you to death, but we will have to skip over some of the things which will hopefully whet your appetite to learn more, but we won't sadly have time to go into absolutely everything. So my ambition today is to cover these 4 key areas. What's the big idea? What is MMC? Why would companies want to use it? Why would clients want to buy products from companies who are using it? And then I wanted to take the opportunity to share with you the key elements that we at NZB believe differentiate the MMC approach to others, and why we're so passionate about the things that we do and the benefits that we believe it delivers to us and our clients. And clearly, the clue's sort of in the name of our company. We use it as one of the key enabling mechanisms for us to drive sustainability by delivering the vast majority of our products as net zero carbon in operation. So let's start with the big idea. What is MMC? Well, apart from being possibly the worst acronym in the history of acronyms, I mean, what does modern methods of construction actually mean? What is modernity? My daughter loves K-pop, this Korean dance music. That is undoubtedly modern, but it's frankly terrible. So modernity is simply not a virtue in its own right. So when we look at what MMC is, I think it's probably as easy to start with a view of what it is not. So it's not construction in a shed, although there are a large number of proponents of MMC who do exactly that. They operate their factory in exactly the way that they would their construction site. They're using subcontract work packages, subcontract labour to deliver that effort. And the difference is the construction site has got a lid on it, so the trades don't get cold and wet while they do their job. And clearly that is a benefit, but if that's all that people are extracting from the approach, then that's a hugely missed opportunity. And similarly, we're not just construction companies who own one of our key suppliers, their superstructure supplier. This is a revolution. This is not a business as usual methodology. This is about doing things differently and making sure that we take the best that industry has to offer across a wide range of different sectors and bringing those together with the expertise necessary from a construction perspective to deliver something which is truly differentiated from the traditional way that we approach the construction and delivery of buildings. We were, as a team, just discussing this just before we went on the call. It's not only a volumetric approach. A lot of people equate volumetric modular with MMC, and certainly volumetric is one of the options, but Mark Farmer, who's a government advisor on MMC, I think this defines 7 different ways in which you can address MMC, and different approaches allow you access to different benefits and different compromises. So we at NZB do what I call pod and panel. So we do produce volumetric elements, but our entire buildings are not delivered solely through volumetric, as the graphic behind this slide illustrates, that we will also deliver pre-panelized walls, and our structures tend to be made of a combination of panels and pods.
Steve, can I just interrupt there? We're not quite seeing your slides progressing. We're still on the first slide.
Right, okay, that's it's progressing okay on my slide, so I'm obviously sharing the wrong screen. Hang on just a moment, and I'll reshare the right version. Right, is that better?
Nothing's changed yet. There we go, something's moved. What MMC is not, that's the slide we're viewing.
There you go, sorry, apologies for that. What I will just very briefly do then is I will page back up to, no, it's not there you go. So that was my agenda, just to make sure people are clear what I'm covering today. What is MMC? Why use MMC? What the key elements are, and how we at NZB use that to drive sustainability. So it's not construction in the shed. It's not just a construction company who owns a key supplier. It's not just about fully volumetric, although that's a very popular version of MMC, particularly in residential. And it's not the killer of variation and innovation. We don't aspire as a business to simply pump out monopoly style product that doesn't allow for us to respect and deliver the client's specific requirements around an individual development or scheme. And finally, it's not actually particularly modern. Ford introduced the first production line into manufacturing in 1913. And while I haven't quite been around that long, I've been doing many of the things that we now consider to be elements of MMC since the mid-1980s. So construction's playing catch up in adopting some of these best practices and putting them alongside the traditional skills of the construction industry. So if that's not what it isn't, what is it? Well, it's a customer-centric, safety and quality first, off-site driven approach to the design, manufacture, construction and finishing of buildings. Now, okay, that's just a more elegant way of saying MMC, isn't it? So let's have a look now then at what the benefits are of doing this, and that then contextualizes what we consider to be the main components. So why would anyone want to adopt MMC? Well, the first reason it surrounds health and safety. Whilst we are able to move activities from the traditional construction site into a factory, we stand a better opportunity of attending to the risks that put my workforce in danger. One of the things that sadly traditional construction still gets wrong too often is that they damage the health of and even endanger the life of too many construction workers. It has the worst health and safety record of any industrial sector. So I could stop there. That's it. For me, that would be a good enough reason for doing what we do. If we can't all go home at the end of every day with our health and safety and mental well-being intact, there's little point in doing any of the rest. So why are factories safer than construction sites? Well, inherently, actually, they're not really. But what it does is it provides us with a platform that allows us to address the risks, which are much more difficult to deal with in the highly variable environment of a construction site. So if you look at the types of things that endanger construction workers, it often involves the risks of working at height. When we build multi-story buildings, the first floor and those above are built at ground level. So we're reducing the amount of working at height that people need to do, and we're reducing the height that they need to go to in order to achieve those activities. We also have a better opportunity to control, for example, the creation of dust and the handling of dust when it is created. Silicosis is the second biggest killer of construction workers. So factories are not inherently safer environments, but they provide us with better opportunities to control the risks, and that's got to be a good thing. And to give you an idea of the scale of the opportunity, I first moved down to this region over 20 years ago when I ran a chemicals facility in North Hertfordshire. We ran that facility for 4 years without a single accident or incident. And that's the standard that I aspire to for all of the facilities that I run, whether or not it's the factory or the construction sites where our products are ultimately deployed. So that's one reason, and in my view, reason enough. Second reason is around the control of quality. One of the other things that traditional construction, in my opinion, too often gets wrong is the huge gap between what gets designed and what actually gets delivered. And fortuitously, the platform that creates the opportunity to control health and safety also provides a better opportunity to control the quality of the product that we deliver. And certainly in our school sector, we have an obligation to do post-occupancy evaluation, and we can demonstrate in that sector. It's much more difficult to do in residential because getting access to occupied homes is more difficult, but we can provide data that shows that in use our buildings perform very close to, or in some cases exceed, the design intent. That's not the case in most traditionally built buildings. The third reason why people turn to MMC is the opportunity to both control and shorten the programme. We'll talk later on this slide and elsewhere in the presentation about cost. We don't have a magic wand to take activity out of the construction of the building, but what we're able to do is we're able to take activities that are traditionally done in sequence on a conventional building site and do them in parallel, which has the impact of shortening the overall programme, and we can reduce the amount of time we spend on site by up to 70% compared to a traditional programme. And that's because we've moved activities that would be done on the building site into the factory, and we do them at the same time that the traditional works are being done in the ground. And so the overall work content is similar, but the time is shortened, and in certain sectors that saving of programme time is enormously beneficial. The fourth reason is that we're in the midst of a construction skills crisis. We haven't been training apprentices for years, although we have recently restarted. And so we have an ageing workforce, and typically the skills are most short in supply in areas where construction is most urgently required. And for many years now, we've relied on skills brought to these shores by workers that come in the main from other European countries. But Brexit is has made that more challenging. It's not impossible. A significant portion of our workforce are originally from Poland, and we've had to work with them over the last year to ensure that they've got the right to remain. And during that process, we did lose a number of people who chose to go back home. So it's not impossible to still use non-UK national workers, but there's definitely a skill shortage. And by breaking the tasks down in the way that we do in the factory environment, we make the range of skills that you need easier to train, and therefore we can open up the work opportunities to a wider range of people who don't necessarily come from a traditional construction background. Oops, one way. The fifth reason, and it's the first time I've touched on sustainability, the factory environment gives us a better opportunity to control waste, both by reducing the amount of waste that we create in the first place, and then because of the permanency of our location compared to the transient nature of a construction site, we're better able, when waste streams are generated, to ensure that that waste is handled in an ethical and sustainable manner, reusing wherever possible, and then disposing appropriately when that's required. And then last, and in lots of cases when you say last, you say, but by no means least. Actually, it is least. MMC is not necessarily a cheaper way of constructing. And in fact, right now, in this embryonic sector within the subsector within the business, it's probably more expensive to produce using MMC. And that's one of the key reasons the government set up Homes England, to provide developers with funding access to ensure that the sector can get traction and get over the setup costs associated with delivering this. And in time, it will become a cheaper way of doing business. But right now, there's probably a modest cost premium in choosing an MMC product, and it will probably be 5 to 10 years before that cost premium fully disappears. So from an NZB perspective, what are the key elements of MMC? And this is a highly personal perspective. If you talk to any number of people in the sector, I'm sure they will offer a different view, but these elements are the ones which I feel are really key to the way that we do things. So the first of those is the rather awkward acronym DFMA. Some people also equate this in its totality with MMC. I don't think it is. DFMA stands for Design for Manufacture and Assembly, and it's a vital component, and I'll talk in a moment about what that means, which differentiates the way we do things with the way traditional construction have done things. Flow is a massively important concept. I mentioned Henry Ford earlier. He invented the flow production line, and flow is an important element of what we do. Standardization, probably the most misunderstood element of MMC, but again, an important component of what we do. What we now call construction quality planning, which is based on APQP, which is Advanced Product Quality Planning, which is well established in all sorts of other industrial sectors. And then last, and in this case definitely by no means least, the commitment to training and development of our staff. So I am going to have to fly through most of these things. Any one of those could take the entire hour, and obviously we don't have that length of time. So I'll do my best to do them justice. So let's start with design for manufacturing and assembly. And in fact, it's not actually that simple, because it's design for manufacturing and assembly and transport and installation and finishing and maintenance and end of life. One of the particular challenges that we have in MMC or in off-site manufacturing is that in a conventional environment where the building is built in situ, the walls are there to keep the roof up, the roof is there to keep the rain and the snow out, so the walls act in compression, transferring those loads through to the foundations, and when the big bad wolf huffs and puffs, the walls have also got to not fall over. So construction materials typically work extremely well in compression, and to a certain extent well in shear. An off-site product has to do all of that, but we also have two temporary conditions that we have to attend to. We pick things up and move them around the factory. So our materials have to work well in tension as well as in compression. And I'll guarantee if you pick a conventional building up from the top, it's going to fall to pieces. Most people call that demolition. We call that off-site manufacturing. So we have to have mechanisms that enable us to pick things up and move them around. And then eventually we're going to put them on the back of a wagon and transport them maybe several hundred miles to their final destination. And so fixings and joints in particular have to be able to survive in atypical in situ situations. So we've got to attend to both of those temporary conditions. And I don't want to build extra fabric into the structure in order to do that. I'd far rather spend £100,000 on a jig or a fixture or a mechanism within the factory to enable me to move everything around safely than build £100 of extra fabric into a building structure which is only going to be required in order to allow it to survive that temporary condition. Because I've built that cost, I've built that carbon into the building for the next 60 years when it may only have been required in the factory for a few hours. And so that's not a good investment of money or carbon. So let's focus on DFMA, because that's a big enough mouthful without adding all of the other bits and pieces. And to illustrate that, I've picked the RIBA work plan, the updated version for 2020, which shows the 5 stages in the, well, there are 6 of them because they start at 0. The 6 stages of the RIBA work plan, and if you look at the right-hand end, that's the one that most people consider to be DFMA. So it's the production of information that represents adequately the design intent of the architects and the technologists to enable those in the manufacturing and construction environment to do their thing. Now, you might guess from the layout of this slide, I am going to introduce you in a moment to the fact that that's not what it's all about, but definitely this is one of the components. So before I highlight the other stuff, let's just have a look at what I mean. Now, that's an exploded isometric view of one of our walls. It happens to be a school wall, starting at the left-hand side. That's the battening on the outside that produces the ventilated void beyond the facade, which is not shown on this particular view. The black layer is the building paper or breather membrane that protects the outer surface of the structure. The brown thing is our main structural element. We use SIPs, structural insulated panels. That's not everyone in the offsite industry uses that. In fact, we're relatively unusual. Lots of people use light gauge steel, timber. It doesn't really matter what it is, but that's what we've got in the middle. Because we use SIPs, we don't create surface penetrations in those structural members. So we also batten on the inside to produce surface voids, and then virtually all of our walls, for both acoustic and fire safety, have a double layer of plasterboard. Now, typically, in a housing development in particular, constructors will often operate with a few drawings, in some cases just one single sheet of paper, which will have a plan view of both the ground floor and the first floor if it's residential, and maybe a couple of rendered illustrations of the elevations to just show the bonding pattern on brickwork, etc. That's not the case for us. That's one wall. All of those elements have got their own drawings, and those drawings have a level of prescriptive detail on them that describes completely what it is that we want the operators in the factory and the installers in the factory and on the construction site to do. I'll pause for a moment on this drawing. So this is the first fit for the acoustic plasterboard, and contrast that for a moment with another industry. If you take a modern aircraft, there are about 60,000 rivets on the external surface of a 777, for example. The specific location of every single one of those 60,000 rivets is determined in the design phase. The people in the factory have no degrees of freedom as to where those rivets go. Their job is to make sure each one of those rivets goes in place effectively and the joint is made properly. In fact, actually on the 777 it's now done by robots, but on the 737, 747 it was all done by hand. This is our equivalent. So putting the plasterboard into the building, okay, it's on the inside rather than the outside. That effectively is the skin of our building. But we rely completely on the skill of the dry liner to make sure all of those fixings go in the right place. And we hope they know that the fixing centres are 300 millimetres apart, or is it 200? And what happens when you go around the corner of an aperture or across the head of a door? And if it's 300 metres, where 300 millimetres? Where's the first one? Is it 150 mil off the floor, or is it 300 mil off the floor? We take all of that chance away by specifying completely where every single one of those fixings and how each one of those joints are made. And what we want the dry liners to do is concentrate on making sure those fixings go in correctly. I don't want my tapers and jointers to walk around, actually as they still do today. This is a goal, not a finished project. I don't want them to need to carry a screwdriver. The first thing that a taper and jointer does is he strokes the wall. You probably can't see my, it's a completely non-value added activity. You see them do this. They'll go down the joints and find out all the screws that weren't driven properly, and then they go and adjust it all. And when you talk to a taper and jointer in a factory, you say, well, why are you doing that? And he said, well, it's always like this. I said, well, why don't you go and talk to the dry liners, because they're actually 3 workstations up, and tell them that you need them to do it differently. They don't have the opportunity to do that on a traditional construction site, because often they're not on site at the same time. The work packages are done differently, and so there's an improvement opportunity that we have within MMC that isn't readily available in the on-site environment. So yes, it's massively important that we describe the design intent to a greater level of granularity than is often the case in conventional construction. And our product has thousands of drawings associated with it, not just 1 or 2. But I'll speak later about standardization. That's one of the things that drives the need for standardization. We can't possibly deliver that level of drawings from scratch for every single product. So we have to find reusable elements that we can make good use of that investment time and time again. But it's not all that DFMA is about, and I'm not going to have the opportunity to go through all of these elements that I'm going to build going back across the screen in the other direction. I will just hesitate on this element of sequence. And sequence is massively important, and it starts to define one of the key mechanisms that we use to drive improvement within MMC. I talked briefly about the fact that we separate the building of the superstructure from the building of the groundworks, or the construction activities associated with the groundworks. So we've taken 2 operations which are traditionally in sequence and in series, and we put them in parallel. But we don't just stop there. If you look on a traditional building site, the first thing we do is we put the walls up. So you've now constructed a cold, dark box into which it's difficult to get both labour and materials. So everything has to happen sequentially. By breaking it apart, we separate the building of our module from, for example, the building of our walls. So we've now taken a second bite at the cherry, and by breaking down the wall production, we create a physical environment where it's much easier to get people, materials and equipment and machinery to both sides of the wall at the same time, allowing a more effective deployment of labour and equipment to deliver things in the way that we want them to do. But we don't stop there. What we're delivering line side in terms of those materials are pre-prepared materials. So we will pre-cut things. You may well be able to hear the factory outside of my window. My office sits above one of the production lines here in our factory. But what I'm looking at is an assembly line. What we've done is we've moved the cutting of timber and plasterboard into a completely separate building, so that I can invest in that building in high performance air handling, so that when dust is created, it's extracted before it presents a risk to the workforce. Just to double down on that, the small number of people that work in that area wear respirator style PPE, which is infeasible to deploy across the entire workforce. And the other risk that's associated with the pre-preparation of material is the use of high-speed rotating equipment, which is another high-risk activity. So I've got a much smaller number of my workforce that need to be trained in the safe use of that equipment. So each time we're trying to separate out the risks, maximize the opportunity to drive efficiency and effectiveness. So we divide, so for example, we divide the task of building a house into 273 different tasks. We then aggregate those together into a number of different workstations, and that then gives us our production line. But it gives us a mechanism for measuring and controlling the work. There are a bunch of other things in here which today I simply don't have the time to take you through, but I put this graphic up just to show you that DFMA is not just about producing drawings, it's about an engagement in the design process, because you have to think about these things from day one. DFMA is not something you can do at the end of the line. Our architects, our technologists, our external consultants and advisors need to understand what it is that we're seeking to achieve so that they can engage with all these things right from the off. Okay, let's look for a moment then at flow. I said earlier that Henry Ford developed the first moving production line for the Model T Ford in 1913. This is a picture of said production line. So the idea has been around for a very, very long time. So what's the magic behind flow that makes it such a better option than static build? Well, the reality is there is no magic, but it is magical. Typically, flow production lines are around 30% more productive than the equivalent static. Good old Henry claimed to actually drive 70% efficiency improvement. When the Model T started, it used to take 12 hours to build one. He eventually got that time down to 5 minutes. The original Model Ts cost $850. It's about 35, 40 grand. Eventually, he got them down to less than $300. That's pretty bullish compared to what many people experience. And in fact, there are very few industries that have recently swapped from static build to flow line to allow us to make that comparison. I mentioned aerospace earlier, and I do that because actually that is one of the businesses that have made that change. And Boeing claimed that when they moved the 737 production from static builds to flow line build, they got this 30% productivity reduction. So what generates that productivity? Well, it doesn't actually, flow doesn't actually tell you what the answers are. It just points you to which of the problems needs to be solved. So to give you an example from the aircraft industry, if you imagine you're the individual responsible for installing the instrument cluster, you climb up the ladders, you go in through the front door into the cockpit. This is a job that should take you half an hour. You get into the cockpit, you realise you've brought the wrong instrument cluster, or you've forgotten your tools, or you can't fit it because the frame that it's supposed to go into is bent. So it takes you 2 hours. By the time you come to get off, the plane has moved down the production line, but your ladders haven't. So you can't get off. So you're going to play merry hell until that problem gets fixed. And to give you a real example from construction, we put our stair string, a pre-assembled string that we buy from the manufacturer, into a pre-made stairwell aperture. And we discovered that the straight string that we bought was consistently 10 mil bigger, wider at the top than it was at the bottom. Now that's a problem because we anticipated that the build crew would lift the stair string into place, hook the bird beak over the relevant joist, put the fixings in place, job done, and they can then move on to dressing the underside and creating the understair cupboard. If actually they've got to wrestle with a stair string which is too big for the aperture, they've got to start trimming plasterboard away, or cutting timbers, or if it goes in at the top, we'll end up with a 15 mil gap at the bottom, which is too big to fill with cork. The guys don't have beading in their van. They don't have a van. This is a production line. Beading was never on the bill of material. So we got the manufacturer in, and the first thing he said was, well, I didn't know that my stair strings were 10 mil bigger at the top than they were at the bottom. No one else has ever complained. We soon find out what the problem was. He started making them at the bottom and putting the treads and risers in. So by the time you get to the top, it's more difficult to get them to close up. So well, why don't we start in the middle and work out? And overnight, the problem was solved. Traditional construction companies have that problem. They just don't know that they have that problem, because actually, if you look at the main skill on a building site, it isn't carpentry, it isn't bricklaying, it isn't plumbing, it's problem solving. So if a site manager says to a worker, you know, Billy, go and fit those stairs in plots number 3, 4, and 5. If they come back to the site foreman and say, Gov, the stairs don't fit, what do you want me to do? He's likely to say, don't bother coming back tomorrow, I'll find someone who can fit stairs. So what they do is they find a solution to that problem. Now, Billy's got a mallet in his van, and so he goes and whacks the hell out of the top of the stair string. But Sharon has got a rolled up copy of the Sun that she stuffs in the gap at the bottom and puts a bit of caulk over the top and hopes for the best. That's why traditional construction ends up with hugely variable products, because thousands of times a day, individual tradespeople are making design decisions which should be being made by people during the design process and resolving those issues before they become a problem on site. Flow forces you to fix those issues because it highlights where the line is slowing. A flow line will only run at the speed of the slowest element, and so you have to fix those problems. It doesn't tell you what the answer is, but it forces you to deal with the issues. So building site labour is typically 30 to 35% efficient. Typical factory labour is 85% efficient or more. We're gunning for that. We're nowhere near that yet. And people from a manufacturing environment go 85%. We get shot if we were as low as 85%. Many fast-moving consumer goods factories will operate with labour efficiency well above 90, 95%. So that's the prize. And the other key philosophy of a flow line is don't make, don't tolerate, and don't pass on poor quality. It's essential you do your job correctly so that the people downstream have got the best opportunity to do their job correctly. Remember the point I made earlier, I don't want my tape and jointers carrying screwdrivers around so they can fix the quality problems that were created by the dry liners further up the line. However, the downside is you've now created a beast. The big difference between the off-site industry and traditional construction is that we've now got a factory. We've now got an employed workforce. We have to feed it with demand. And that's one of the key areas that generates the cost premium in MMC. While people are still coming to terms with the sector, the demand is lumpy and bumpy. And we've got to distribute those fixed costs associated with a factory as best we can. It's one of the things that drives the discussion about automation, and we haven't got time today to go into that. I mean, going back a long way, by background, I am a robotics engineer. Back in the 80s, I programmed some of the first robotic production lines in the UK. And my ultimate dream, my retirement goal, is to produce a fully robotized MMC factory, but we're years away from that. We need to crawl, walk, run. Investors love flashing lights and robots. It's too early to dive into automation. There are lots of low-hanging fruit. There are lots more better options than going straight down the automation route, because the more fixed cost you build in to these factories, the bigger the beast becomes and the hungrier they become in terms of their need for demand. So let's move on to standardization. I said earlier, and I'll repeat here, it's one of the most misunderstood concepts within MMC. Henry Ford famously said of his Model T, you can have any color you like as long as it's black. There was no choice. And people have interpreted that to mean that standardization means everything is the same aesthetically. Actually, Ford's factory concepts were built on the work of a gentleman called F.W. Taylor, who invented scientific management. He was focused on time, not aesthetics. And so the reason Ford chose black as the color is that every different color of paint takes a different length of time to dry. And so if you have lots of different colors of paint going down the line's got to change speed. It speeds up and slows down. He chose black because actually black changes, dries more quickly than anything else, because the black color absorbs the heat in the oven. And ironically, black is a cost option now on a Ford. So it isn't about everything, making everything the same. So it doesn't mean that you can't have bespoke elements. It doesn't mean there's no room for innovation. What the challenge is to reduce the impact of that variety. So how can we have different elements that can be done within the scope of that element of work on the line? So how can I have a different kitchen configuration which still allows me to put kitchen A or kitchen B into that module in exactly the same length of time, ideally for exactly the same cost? And then what we've done is we've removed that element of variety. And that's about standard details. It's about standard fixings. Lots and lots and lots of things in MMC are about the fixings, how things go together rather than the components themselves. And then ensuring that those differences can be achieved in the same time at the same cost. This is a very busy slide talking about construction quality planning. I could talk about this all day. You'll be very glad to know that I'm not going to. It's a multifunctional approach. At the heart of it is an integrated management system that says we're all sharing the same data or creating a common data environment to enable people outside of the organization to share that. And we're working to a set of agreed standards that allow us to develop the product design to an understood specification, to develop the process design alongside that, to validate both the product and the process design, and to use yet another acronym, the plan, do, check, action, to make sure that all of that works. And then BIM is the digital Viagra that enables and empowers all of those things to work effectively in building information management. So I could talk for a whole hour or more on just that one slide, but I'll leave it at that if I may. And then finally, and by no means least in this case, the training and development. This can only work if the companies who are trying to do MMC are prepared to invest in the workforce. That's why we can't deliver MMC through a wholly contract labour force. Now, yes, we have contractors in our factory, and on our building sites, we do deploy work packages through subcontractors. It's a fundamental part of what we do. It's one of the mechanisms that we use in order to minimise the disruption associated with the volatility of demand. But we've got to face up to the fact that more skilled workers are leaving the sector than are joining. We need to migrate from that traditionally skilled workforce to specifically trained workforces, and we're starting to make a reinvestment in apprenticeships. We developed a scheme with Cambridge Regional College. Our third cohort of apprentices starts later this month, and we need to invest in skills and training, not just amongst the factory workforce, all of our professional staff have personal development plans, and we need to invest in their continual development as well. This does not come for free. We need to make the sector more accessible and more inclusive, and we need to invest in our workforce to make sure that people see this as a sector worth joining. I don't want it to be a sector where you just put the troubled kids, the difficult ones in school that you can't think what to do with, so you put them on the bricklaying course, or the clever guys go into architecture, don a bow tie and never go near a building site ever again. This needs to be a sector that, and it is. I mean, you know, we build smart buildings. We wherever possible, wherever the client brief will allow, we will put a fully functional building management system into the building. So we need electronic specialists, we need control engineers, we need architects, we need technologists, we need engineers, we need people who are interested in sustainability, in thermal performance of buildings. There isn't a educational discipline that doesn't have a place in modern construction, and we need to make sure that we're all collectively working to make sure that this is a bright, interesting and dynamic place for people to spend their entire working career. So you'll be pleased to know that those are the elements that we think are important, and I'm almost at the end of my bit. So how do we use all of that lot to drive sustainability? Well, the key to this is doing what we say we're going to do. So it's using the control that we get through the factory. It's using the APQP or the construction quality planning approach to make sure that we are designing processes that guarantee the delivery of the design intent. So what gets built, what gets designed, gets built. And our fabric first approach ensures that we can deliver highly insulated, relatively airtight superstructure. Now, you can do that traditionally. I often say there's nothing that we do that traditional constructors can't do. It's just that they don't do it, or they find it really hard to do. So typically we'll be delivering walls with a U value or fabric of the building which is better than 7 watts per meter squared. That's good, but it's not fantastic. It's nowhere near the levels that you would expect from a passive house, but it's good enough to deliver a zero carbon in operation structure. The one that traditional construction really struggles with is airtightness. You don't want a building that's going to leak all that air you've expensively put energy into to keep you warm. I understand, although I've personally never measured it, that the typical building in the UK achieves an airtightness about 11.5. A good result for traditional builders would be somewhere less than 5. We consistently deliver below 3. Again, that's nowhere near the less than 1 that the passive house guys would argue for. But I think it creates a pragmatic compromise between what's achievable, the amount of carbon that you need to embed into the structure in order to deliver that, and delivering something that delivers real tangible value. So a house built to those specifications with the solar panels and the air source heat pump that we put in place as well will typically have a monthly energy bill of less than £20 a month, and significantly less than that during the summer when the solar is working at full tilt. And our own carbon footprint as a producer is being measured. We're in the process of doing that now. It's not an easy undertaking, but it's made more feasible because we have a permanency associated with the factory. It's much more difficult to do that when you occupy a building site for a relatively short period of time. And we can put in place effective and realistic plans for us to drive down our own carbon footprint, reducing the amount of carbon that we then embed into the buildings. And I said earlier that we eliminate waste wherever possible, and where it is produced, we handle it in the most ethical, sustainable mechanism that we can. So that was very high speed. I've gone slightly over my allotted time, so apologies for that. But thank you very much.
Thank you, Steve. And that was really, really helpful, really good. Enjoyed that a lot. We're also now joined to continue the conversation, some expert summarisers. So it's like Match of the Day, but without Alan Shearer and Gary Lineker. So instead we have John Dixon, who's an architect, partner at Ingleton Wood in Norwich, Adam Simpson, who's a building services engineer, director at Clear Consulting and Design, and Daniel Key, who's a quantity surveyor and director at Richard Utting Associates. So I'm going to stop sharing the screen now, so hopefully you'll be able to see their faces as they unmute their microphones, and by magic of television, we are all present. So yeah, over to you guys. Hand a conversation to you to sort of pick Steve's brains and discuss amongst yourselves, but probably starting from the beginning of the process, I think, Daniel, and that's a client's perspective, and often you're brought in at the early stage for feasibility and things like that, as much as John Dixon would be from an architectural point of view. So what are your thoughts on the trends and the appetite within the sectors that you represent?
I suppose my background is obviously predominantly residential, so I think it's beneficial to start there in that sector. Clients, there's always a drive to use MMC because that's where we need to get to. We need to reduce energy consumption, and we need the buildings to perform better. So I think we all understand there's a benefit in doing so, but I think we all get stumped by the cost piece, and secondly, clients needing to have a sort of a frozen design RIBA stage 4 well in advance of sort of site commencement. So that are two challenges I see. Plus, I think often clients like to consider almost like infill sites for MMCs as like a trial, if you like. It needs to be sort of a mass site of sort of 50 plus is the niche I've been told in the past. So there's a number of questions there, Steve, but I think the first one for me is cost. I noted in your presentation you said you believe it's sort of more expensive. You didn't actually tell us how much more expensive it was. You were quite guarded in that in your response. Now, obviously, MMC, which we're assuming a SIP panelised system in terms of what you presented today. Now, we have cost data, but I'd be keen to see where you believe that sits only above a sort of a traditional construction.
Yeah, so the water is slightly muddied for us because we are also delivering a net zero product as well. So there's a cost premium associated with both of those. Combined, for the residential sector, we're possibly as much as 10% more expensive than the non-net zero traditional equivalent superstructure. Now, in theory, because our product is substantially lighter than certainly a traditional block and brick structure, then the foundation could be lighter weight, and we certainly have got more flexibility in foundation solutions. Being totally honest, we rarely deliver a cost benefit in the ground. So when the 10% I'm talking about is the is the superstructure cost.
And just interestingly, we're often led to believe because you get efficiencies on site, there's a prelims efficiency to the main contractor. So when we've done cost studies in the past, we can almost make MMC a cost neutral solution with the right product. I don't know if you found that in your experience, Steve.
Yeah, there's definitely an on-site prelims benefit, 100%. I mean, we would claim, although it does vary depending on the nature of the site, to be on site for maybe as much as 70% less than the traditional equivalent. And so obviously that has a huge prelims benefit, but it is at least to an extent offset by the fact that we've got the establishment costs of the factory to cover, which is a permanent fixture. If we can keep the factory busy, then I am confident that we can generate a cost neutral solution.
You're talking about in your case there, Steve, sorry to interrupt, about the using you as the main contractor in the project, or are you being a subcontractor underneath a main contractor and they were paying extra on top of that as well?
So it varies. My preference is for us to act as the main and the principal contractor. We don't do our own groundworks, so that is always a subcontract work package. But we're delivering a housing scheme at the moment where we aren't the main contractor, we're only the superstructure subcontractor. And it always creates a headache around who is actually responsible for the foundation design when you end up with something that's not quite right. And the tolerances that we demand, I mean, for the first instance, we talk about tolerances. So we have a specification around the height of the foundation there. If we're landing on piles, for example, the pile caps need to be +0, -5 across the entire row, because we can shim up to 0 when we land the module. Lots of ground workers don't really understand what on earth we're talking about, and very few of them can operate by +0, -5. Are we talking fists or are we talking millimeters? I'm talking millimeters. So there is a real challenge there in us simply acting as the subcontractor. It works much more effectively when we're the main contractor.
Daniel, did you have something else to add there?
I was staying with my cost piece, and I suppose where I'm coming from is materials we're being told are continually on the increase, in particular timber, and obviously not helped by the Brexit transition. Are you finding that's causing an impact on your?
Yeah, I have to say that the worst excesses that we were led to believe were coming our way, at least as of today, touch timber, haven't come home to roost. You know, we were told a month or so ago that we could see up to 100% increases in structural timber prices. Supply has become more complex. Our preferred facade for our schools products is a vertical cedar plank that we import from Canada. It now has to come the wrong way. It goes down the Pacific coast and through the Panama Canal and up there, rather than coming directly across the Atlantic. So there are price pressures. Structural steel is the next one. We've been told to expect, again, up to 100% price increases in structural steel. We have seen some, but at the moment it's manageable. But there are definitely price increases coming. But I don't think we're impacted any worse than a traditional constructor.
No, I'd agree. And sorry to hone down on the point of cost, given that's my background, I'm going to keep teasing and asking that question, Steve. When we've priced in the past, just a crude sort of cost per square metre, we price on the gross internal floor area. For example, the frame, the roof structure, upper floors, etc., would be in the region of, say, I don't know, £175 to £200 across the square metre of the building for the SIPS solution. Is that sort of where you see the cost base for your product?
So we also produce by gross internal floor area. I think it would be commercially sensitive for me to give our precise number, but it's nowhere near the number that you just talked about. It's much nearer the 100 than the 200.
Okay, that's good to know.
But it's not below. I mean, with some traditional constructors claim to be building houses for, you know, £80 a square. One, I'm very sceptical about that, but I'll hold my hands up. We can't do that. We are above 100, but we're not that far above.
Okay.
Thanks, Daniel. And John, and keen to bring Adam into the conversation as well in terms of sustainability, and from John, from your point of view as well, design and clients' perception of the word modular or MMC and perceptions around detail of design and quality from an architect.
It's obviously we've been using MMCs of various sorts for a long time now, going back to timber frame and all sorts of things, probably the last 20 years or so. And we at one point we had our own sort of volumetric product that we evolved with some people are probably on this call at one point. And there were always challenges around the reality of the volumetric product in particular, which is about mechanics of flow, and what Steve very much picks up on there is about flow through the factory in his case. I think in our case it's very much about flow demand from sites and from clients. So yes, we establish a product very much the same way that Steve does, then trying to get that flow to continue was the challenge. But then we had logistical challenges as well, like things like access to sites. So, and then police escorts and all those things associated with volumetric became a much bigger issue for us, which in the end stopped the flow happening, became a real problem. So I think probably, Steve, your approach on the MMC side as far as panelised products is concerned might be a smarter answer. Certainly our experience as a business over the last few years really has been a lot in panelised products, things like St Anne's in Norwich, things like Carrow, which are going very well now currently, and St Giles Park in Cringford also are all great examples of where MMC systems are being used. My personal issue sometimes is about the way in which we look at design as a whole, and we develop our nice traditional little brick boxes that we all like to live in and people like to buy for a certain price that sellers can sell delightfully. But it seems a strange and ironic situation that we build up these panelised systems, and yet one by one we stack a brick up at the outside. We're seeing the world changing on that now, which is really nice to see, and we are getting the whole panel being built. But I wonder from Steve's point of view, or from Daniel, what the appetite is for changes for us, seeing those materials actually manifesting something about the process, not just about what we want to see as replicating what buildings used to be.
Yeah, one of the photographs that was embedded within my presentation is a photograph of the two show homes that we've built here at our factory between Newmarket and Cambridge. And the brief when we did that, which is at the back end of, I think, 2018, was, as you've suggested, John, let's build a product that looks as much like the sort of thing that you'd see going on to a Barra or a Permisson or a countrywide development as we can possibly get it. So let's use a brick facade. Let's have a product that looks ultra traditional. Because at the time we were concerned about the negative impact or the negative conversations that people have got around off-site and prefabricated, remembering the dreadful products of the 50s and 60s that are still around us today. But and bearing in mind our residential product is predominantly aimed at the PRS market, and so most of our clients are public sector or housing associations who've lived with the estate legacy of the prefabs of the 60s and 70s. Modern day products very different to that. Actually, an aside, but the fascinating difference between the two sectors is that our schools customers never ever want to come to the factory, unless it's to bring kids along to see what factory manufacturing is all about. If a schools client wants to see a school, they want to see one we've already built, because they want to talk to the teachers and the pupils about how does the building actually work. The housing customers always want to come to the factory. They want to kick the doors in the show homes because it's much more difficult to get access to an occupied house. So they, pre-pandemic, they used to come, every couple of weeks we would have a client come along. And during the late part of last year, the early part of this year, the most common feedback that we got was, isn't it a shame that you weren't more architecturally ambitious in the external treatment of the home? And the scheme in Norwich, the Sterling Prize scheme in Norwich, has helped to shift the dial, I think, on what people are prepared to accept as modern. And so we are getting all sorts of inquiries about much more ambitious facade treatments. We can be very, very flexible in what we put on the outside because it's a non-structural element of our build. I would love to persuade people to go for asymmetrical roofs. NetZero is much easier to achieve in a school, particularly a single-story school, because there's acres, sometimes almost literally, of roof space that we can put photovoltaics on. Because the Brits love these, pointy triangular roofs, only 50% of which is any good for solar, and it's a much higher occupancy per square metre of roof structure. It's much more difficult to achieve net zero in a residential property than it is in a school. So if we could persuade people to have a roof with a major aspect facing south, then my life would be much easier.
I think that brings Adam in quite nicely, though, in terms of sustainability.
Yeah, indeed. Thank you for the presentation, Steve. That is very informative, and also the sustainability credentials that the homes already command are really important. One of the things for me from an MEP services perspective was that whilst you talked a lot about the DFMA and how it was executed in stage 5, so 6 of a REBA stages, or REBA stage 5, the actual decisions to go down an MMC route are made at stage 2, much earlier in the process. And I think to make this successful, the integration of MMC has to be had by us as a team much earlier than we currently even consider it. From an MEP services perspective, making some decisions about integration of services very early on, designing with MMC in mind, is really important, because the generic tender that we tend to send out when we procure a job, where we go out on stage 3 information that doesn't have any specifics of how we expect it to be constructed or has a notional idea of its construction, tends perhaps to dictate the way it's constructed. Those things that need to be obviously integrated together. I think I don't know what your thoughts are, but I think we might have to flip some of the decisions we make in our construction and our procurement.
Yeah, I agree completely. I mean, one of the most frustrating things is that, particularly with housing associations, the first thing we have to do is derogate key elements of their ERs, because lots of them specify a gas boiler. We don't put gas into any of our properties. The heating is all electric. It's either done with heater batteries in the airlines, because we're operating with pretty low levels of or pretty good levels of air tightness. We will always fit an MVHR, a mechanical ventilation and heat recovery system, because we need to mechanically handle the air. I fight to keep that. Lots of people don't like it because they're a bit funny, and it's a funny set of letters, and it's tech. The true fabric first guys hate it because they want to do everything passively if they can. But I think the sustainability isn't all just about carbon. There's a much bigger agenda, and I think air quality is going to become one of the next big agenda items for the constructors of buildings. There's evidence, if you look at the mortality rate data that's coming out of New Zealand, where through the pandemic they've actually reduced their levels of mortality rather than increasing it. And one of the theories behind that is that air pollution is potentially a much bigger killer of people than people are given it credit for. So I want a mechanical handling system in there, so that we've got the filtration if we need to put HEPA filters in, we've got that chance. So we don't put gas in, we heat in the airlines, and we don't put wet central heating systems in unless we're forced to. So it's all done through air. Occasionally we'll put an electric panel heater in or an IR heater in, but we try to avoid those if we can.
And I think there's an interesting conversation to have about integration of services and your desired services solution. You know, the use of an MVHR is pretty standard. Obviously, it is a passive house strategy. It's something that's got a lot of traction in the industry, has all the good, bad and ugly reports you can have about it, but it is there for good reason. With an air permeability of less than 3 as well, it provides you an energy benefit. Interestingly enough, if the property is leakier than a 3 under the SAP calculation, it actually gives an increase in on paper energy use. So it actually contradicts itself if you were to stick that in. And I think that one of the important things for me has always been, whether we call it volume, panelized systems, whether we talk about podded systems, is about that differentiation between the in-factory commissioning and type testing, and then the on-site testing and commissioning as well. From an MEP perspective, you're installing it in a much more controlled environment, so the quality of the installation is usually very, very good. There's no doubt about it, and you have your own QA process. Many manufacturers do, but then that is picked up and it's moved to site, and it's moved and it rocks and it does its job. If you're trying to build a passive house-esque MVHR system and then you pop your 2 pods together, the ductwork within that pod has obviously moved and transitioned, and therefore it could have come loose. And so that understanding those division of commissioning is really important. That stage commissioning is a really critical part for me when it comes to MMC.
We need a lot more help to make progress in that. I mean, if you look at the hydraulic systems rather than just the mechanical systems, the problem's even worse. If you look at the manufacturer's specifications, they talk about the need to do a high pressure, a 20 bar first fix pressure test of the hydraulic system before you fitted any of the accessories. That concept doesn't exist in modular, because we never create a fully connected first fix of the entire property without any of the accessories installed. So yes, we can do a 20 bar pressure test on the bits that we do, but when you add them all together and you've got your radiators on and your taps on and your other elements, you're limited to doing a pressure test at 5 bar. So when it leaks, you know, the suppliers turn around and go, well, it's not our fault because you didn't follow our manufacturer's instructions, but clearly say you've got to do a 20 bar pressure test. So there's work to do to deal with that stage installation and commissioning.
Yeah, and that brings you to the thing, the statement you made, which is really important, that the MMC doesn't mean sacrificing quality versus speed. It just needs to be managed appropriately, and the appropriate method statements to manage that process. And from an MEP perspective, it's always something I've been very focused on, all the way from specifying concrete bathroom pods and having push fit plastic fittings fail because the manufacturer said it was the way the pod was installed. The pod clearly got bumped on the way up into the high-rise building, and you have to do a lot to a concrete bathroom pod to dislodge pipework fixed to the side of a concrete bathroom pod. So, you know, it brings into question the type testing, but your quality management, the IMS, obviously, like you said, you could talk for days, couldn't you, just about that alone? And I haven't mentioned at all NetZero, because I think I could also talk for days with you about NetZero. So I'm gonna leave it there because that's a whole other conversation.
One thing to just pick up on as well, I think we're talking a lot about, you know, the maintenance of the speed of construction and the importance of that. And I think sometimes, you know, and we look back on the work we did with the first things we did about trying to fit them on the back of a wagon, and you look at the dynamic impact of those limitations on space and how that actually impacts on how people will live in that house for the next 60, 100 years or so. I think we really need to make sure that we're remembering in the process of the focus on the speed of construction, the economics of it and everything, we are building places for people to be educated in, people to live in. And that's actually the end goal on this, that we're trying to create good quality spaces. So quality of construction, yes, is important, but not at all cost of speed of getting there quicker and making sure it's the cheapest thing we can. It's about endurance, because it's a little, you know, a house is a long game. And we're only talking about that, sorry, a house or an education facility or whatever is only one part of that whole whole lifespan of a building. It's key to keep coming back to why we're doing this. That's quite important.
Yeah,
Yeah, I agree. I agree.
When we talk about the whole of the net zero agenda, the lifespan of the building is really important. We assure our product for 60 years. I'd like to extend that to 100 years. I actually think there's much better benefit from a carbon point of view in finding mechanisms that enable the building to be used for a longer period of time than working out how to deal with the end of life at the end of 60 years. But as John says, that absolutely, particularly for residential, that means we've got to be looking at houses that can be adapted for changing needs over the lifetime of the resident, so that we can add lifts, we can add accessible bathrooms, and we can change the configuration of the building without having to knock it down and start again.
Thanks, Steve. We've got a few questions. I'm just mindful of time as well. We've had a few questions come in from our viewers today. So Robert at Redhead Architects, Daniel mentioned 50+ units for housing. Is there a minimum size value for individual buildings where MMC becomes cost effective? So I guess he's saying, is there a sort of a minimum order, or is there a sweet spot really to go into production for you?
From our point of view, as a supplier, we'll do a semi. So we can do infill sites. There's a construction site establishment cost that you've got. There's prelims associated with that, which aren't all linear. I would agree with Daniel that there's a sweet spot around 50 to 100 that makes it really attractive. Once you get above that, there's almost a case for building a local factory and reducing the transport vector.
How does that work though? Because most developments we do. Sorry, I'm conscious of the time as well. But most developments we're doing are between 30 and 50 units. So the majority of most people's development packages are 50 or so units, 50, 60 units. Are we ever going to get this product or this sweet spot for you guys to work in conjunction with the housing developers, if you're doing that 61 there? Because that's housing developers as such, you aren't necessarily looking to you. They're driving their costs down. They're using traditional methods of construction because they can buy that cheap. You need to get those two things together to get the world to start being able to access your product. Because as we know from this discussion, your product at the minute is more expensive than what the mainstream contractors can go and buy off the shelf. What helps us to bridge that gap to get those two things together? Because at the minute we're saying it's not. Your sweet spot is beyond what the market really wants to do.
Yeah, I mean, I think the sweet spot is driven by actually the point that you made earlier, John, which is the need to maintain flow of demand, and so if we can balance that out, we can drive down that economic order quantity to something that's more in line with what's required. One of the interesting challenges, I remember early on in my lifetime, standing up in front of a bunch of developers and exclaiming to them with glee that rather than build 5, sell 5, build another 5, sell another 5 that the developers normally do, I can deliver you all 200 homes in the course of a couple of weeks. And the ashen faces that I looked out on among the audience, and they say, that absolutely destroys our cash flow. We don't want that at all. So what we actually need is multiple schemes simultaneously, so that we can deliver product to different sites at the same time and balance the demand coming through. So I don't only want a factory making Model Ts, I want a factory that makes multiple different products at the same time and helps me to drive my economics. So I think that's how we attack that sweet spot.
Thanks, Steve. We could talk about this for hours. I think we'd probably have a whole series of podcasts if we wanted to, if we had a day to spare to record them. Another question in from Joe Jones at Clancy Consulting. Talking about MMC is obviously a big push from the government to try and find efficiencies in their national construction programs, whether it be in the health sector. But Joe's talking specifically about the education sector. And basically the question is, are we thinking the government will invest more funding into new MMC schools over the next 4 years? I know there are frameworks there that predominantly are just for MMC in education. But are you seeing more direct involvement from them in terms of mobilising your factory and understanding your capacity to deliver that? Because it's all well and good, I think, government initiatives saying we're going to push it, but if we can't deliver it, we're going to have the same problem we've got with traditional construction, haven't we?
Yeah, so the current education framework is known as MMC1. That's a £5 billion framework spread over 5 years, and we are one of the 10 participants on that framework. And we're currently delivering about £65 million worth of schools through that framework. It started virtually this time last year. Prior to that were a series of modular schools frameworks, Mod A, B and C for big, medium and little schools. And when Mod A, B and C were running, the working presumption of the Department for Education was that each time a school came up for appraisal, they would consider whether it could be done by MMC, and it would be put through the mod frameworks if it could be. Otherwise, it would be let through the National Construction Framework. With the introduction of MMC1, the DFE have swapped that presumption. So the presumption is that all new schools will be built using MMC techniques unless there's a reason why they can't be. Some of the very, very big schools are still going through the National Construction Framework, but we're being told that the 5 billion is likely to get bigger, not smaller. Boris announced that he sees construction and specifically schools construction as one of the most effective fiscal stimuli that he'll use to develop, to restart the economy, and has already promised an extra £1 billion of schools. My understanding is that they'll all come through the MMC framework. That extra £1 billion will all come through the MMC framework.
Brilliant. And the last question, I think John's volunteered to answer that, thankfully. We're all sniggering.
I think the comment that Saul picked up, and the same as I made a note to myself that I'm going to describe from here on BIM as being digital Viagra, because I think that's the takeaway from today's presentation. I quite enjoyed that, actually. Whether it is, as Saul suggests, the answer to the workforce of the future, I don't know, but hey, let's give it a try.
I have no knowledge of that subject, so I thought I'd let others answer that. Thanks for the question, Saul. Hope everything's all right. I think we're nearly there. If any of you other guys on the panel have got any burning questions, desires, or summaries, looking blank, brilliant. Move on. Really grateful for everybody spending an extra half an hour with us today. I think it's been quite helpful, just having some other voices at the end of the presentation rather than mine. And really thank Adam, Daniel, John for joining in the conversation. I think it's made it a lot more sort of vibrant and contextual to everybody's expertise and field of knowledge. So thanks very much, all three of you. And thank you to Steve for your presentation today. I'm just trying to go back to my presentation. And there we are. So that was today. Coming up next month, we have Mike Burrell, who's the Greater Norwich Planning Policy Team Manager, and he'll be discussing all things planning. So that's the local plan, which is at very advanced stages, and they've had quite a lot of challenges along the way with that, I believe, and obviously the government white paper planning for the future. So Mike will be joining us next month to share his thoughts and insights into that, and that will be sponsored by One Planning Consultants. So I hope you can join us for that. And we are on a roll. We've actually got the next one already booked in as well for March. And that would be Patrick Campbell. He's a deputy agent for the Bank of England, fulfilled the same role that dear old Tim Pike used to fulfill for the Bank of England. So he's the new man on the block, and he'll be able to share his insight into the economy and try and relate it to our sector and construction and the built environment. And that event will be sponsored by Create Consulting. So thanks to them. And another reminder, the awards are open, and it does capture both years from 2019 and 2020. So it's a really good opportunity for you to look back and recognise all the great work that you've been involved with. and submit some award applications, and that is open for the next month or so. Many thanks for sponsorship today, Clancy Consulting. Again, I'll say at every event, without our sponsors, we wouldn't be able to afford the Zoom license, and I would be talking to myself in an empty room. So thank you very much to Clancy for supporting us today, and a special thank you to Michelle Chambers from Clancy Consulting, also a committee member with us, who's put an awful lot of effort at the last minute trying to bring this event back together, obviously with the difficulties we've had with our previous speaker enjoying the birth of their new child, and congratulations to them once again. So we are there, end of the show, and I'll just play out with some good news and some nice feelings from previous years when we had our awards, and I wish you all the very best. Be kind to each other, be safe. I'll see you next time.